Don't buy a scanner or a scanner app, rather build your own with just 25 lines of Python. This is super easy, super fun and super crazy, so let's get it started. Before getting into the detail, please like this video and subscribe to this channel. Otherwise, grandma will scan your full body and find 3 cockroaches inside your brain. To start with this project, you will need a Python code editor and I would be using PyCharm. Once PyCharm is ready, just click on this new project button and give some fancy name like a smart scanner, something like this. And once this project is ready, all you need to do is to install 2 simple packages. And for that purpose, we'll go to the file and then click on settings, and wherever is the name of the project, click on these 2 and project interpreter. And here you will see like 3 packages. So I will add 1 more packages and I will click on this guy. And here I will write opencv and then contrib, and I will select opencv contrib python and install this package. If you face any problem to install this package, I will have a link of Discord and you can go there and you can ask as many questions as you have and we will solve each one of those. And the next package we will be installing is called pillow, and once the pillow is selected, I click on the install package. And once this is done, I would just cross this guy and you will see we have pillow, numpy and opencv contrib. These 3 packages added in our project. I will click OK, and here I will close the sidebar and I will press Ctrl A and backspace. Now you need to think about how you would scan the image. For example, if you want to scan this guy, how you will scan it? One option, it could be you just hold like this. The problem is your hand would be coming, so you cannot use a video camera built-in webcam to do the scanning. Second option is that you can take your laptop some kind of crazy way and open it something like this way and then take it the right position, and that's not very much user-friendly way. You would not be able to see what's on the screen and you would not be able to press the right button to save it, and that's not fun either. Then third option, you could be smarter by using a smartphone, because if you are running the project on your computer, take the smartphone and it will go to the right location of the image you want to scan. You can just put it on the table and you can put in the right place to scan it, and that's the fun part of it. And to do so, we would be using a simple app, and that's called IP webcam. And you see this IP webcam, right, this one. So if I open this guy, and it will give you a lot of different options. So the only one thing we would be focusing on in the middle one is called this video preferences. So if you open the video preferences, you will see there is video resolutions. I am using little bit larger so that I can get a good picture to scan, and I am using a 1920 1080, and same way you can update the photo resolution whatever you want. Currently I am using 1920 and 1080. And once you are done with video preferences, you can go one step back and then scroll all the way down and you will get start server. So I'm clicking on this start server. Once you open the start server, it will give you an IP address. This is very important. So I would be using a better camera that I got from my Jeff Bezos uncle just to record this video, and once this record is done, I'm sending it back for free to my Jeff uncle, but don't tell this to my Jeff uncle. So once I got this IP address, all I need to do is to open this IP address in the browser. So I'm going back to the browser. Here I'm typing the right IP address, which is for my phone is this guy. And this, if you want to see the video right away, you can click on this JavaScript. You see, this is the live video and I can see this is the camera, right? So, and by using this, I can actually scan very easily. And to use it with PyCharm, all you need to do is to right click on this guy and open image in a new tab. This will give you the image of that moment right here. If you change your position, say for example you hold like something like this fancy dude and you refresh it, you will get the latest. If you do like thumbs up, doesn't matter, every time you refresh or you reload the image, you get the latest version of it. And all we need to do the URL. So I can get rid of this query string whatever after .jpg and press A to select everything and Control C. Now we are all done with IP webcam and we can put the URL in a variable called URL and we just put it here. To open this URL, Python has a fantastic, very simple packages and we will import that dude. And this is from URL library. We want to get the request and we'll give a small name called request. And now all we need to do is to use the URL library to open the image again and again so that if we move or do something, it always captures the latest thing the camera is seeing. And that's why I would be running a while loop. And since this while loop would be running forever, that's why we put like 1 or true after this. And once we put the true inside it, first we will open the image. And that's why we'll call the request, hey request, you need to open the URL, which is like URL open, and then you will pass the URL to it. This will give you the object of the URL, but the way images works in a computer that it stores all the information of an image. If you look into this image actually have like a 1900, you see like a 1920 pixel this way and 1080 pixel this way. That means if you multiply these two, that many numbers of data it is stored, and most of the times like a 3 times of this. That means it stores like a 3 different color layer by layer. We get to know little bit later of this video that how images works. But all we need to do is to convert this image to an array. Then we'll convert it to a NumPy array and then eventually we get the image and we'll be seeing ourselves. That's the fun part of it. So the next part is to convert image to bytes, and that would be by default bytes array, and we'll pass the image and we'll read whatever inside the image. So inside the bytes array we are passing image.read. And if you have done this nice way, the next step is to use NumPy. We already installed NumPy when we installed opencv. So we'll be import NumPy and we can give a short name called np. Here we can convert it to image NumPy, and that would be, we will call NumPy.array and we will pass the image bytes. And here optional, you will part the type of the data you would be storing on this NumPy array, and you can pass np and then this would be unsigned 8-bit integer, something like that. And the next part is to convert it to a frame, that a frame that would be running one after another to show you the video. And that's super easy. All you need to do is to call cv2. We already installed cv2, so we'll import cv2 and here we will tell, hey cv2, you need to decode the image. That means I am decode. And once you decode the image, all you need to use the image np and pass one extra flag. And this flag by default will put like a -1. That means you do not change the image. And if you pass 0, that means the image would be grayscale. There are a few more flags you can use. And after that, you just need 2 more lines. The first line you call cv2, hey, you need to show the image. That means image, which is I am, and then show. And the first thing is like my smart scanner. This is the name of the pop-up that would be opened, and you want to display the frame. And the last one is cv2 and wait key, and this is you are telling how many milliseconds, if you press on the key, how many milliseconds it need to wait. So if you have done these 10, 11 lines correctly, if you open, you see the black and white version of yourself. And if you want to make it colorful, remember we put this flag, and if the flag is 0, this would be grayscale. If we put -1, this would be unchanged. That means we'll see a colorful version of us. So we are done with our step number 1. Second part is actually scanning something and saving it. So that's the exciting part of this video. So in this step, we would be using this camera to scan something and save it, and that should be the fun part of it. And doing the scanning and saving it just pretty much like a 3-4 lines of code. And first you need to think about that how you will save it. Definitely you will press something on the keyboard, that could be Ctrl S, or simply you will be press the key S on your keyboard. So if I just make it a condition, because this is for, it's waiting for the key to be pressed anyway. So I am checking whether you are pressing on the key S. And if you are pressed, just first check whether the printing that you are being pressed something or not. So I'm just printing save. So I'm clicking on this guy, and if I press S on the keyboard, you see save. If I press S again, you see save. But if I press like my X, right, it doesn't do anything, or W or Q, it doesn't do anything. If I press S again, you see this is the output. That means you are able to press a key on the keyboard and detect it. The rest part is like maybe 3 lines, because we already installed pillow. So we can tell, hey, from the pillow, in the short form is PIL, for PIL stands for pillow, and I want to import image. They have lots of sub module, and we want to get the image one. And once we get the image inside this, all we need to do, maybe I will keep this line just to know that this is actually saved. So I will create the image in the as a pillow object, and we'll call, hey, image which we got from the pillow, you need to do something from array, because the frame is nothing but an array. You can look into this if you want, because frame has bunch of elements in a large array. You can just console log frame to see how big of an array it is. But anyway, once you get this pillow object of the image, all we need to do, call the image pil and then save it. Here you can give some name, say for example my scanned item, something like this .pdf. That's pretty much it, and this will save it. So I have this item that I want to scan, and I'm putting on top of it, and you will see the output right now. And if I click on this dude, you'll see this already here. And if it is not right in the focus, you can make this item as close to the camera on the table or whatever the surface you are doing, and then change it right in a good space, and you can press S on your keyboard. And if you have done this correctly, you can just see it as an output. So here, if I open the side menu, you will see my scanned item, and I can right click on it, open in Explorer, and if you open it and then you double click on it, this is your scanned output. Isn't it cool? And you could become exciting, and then you can go to here, my scanner, and put something else. Say for example, I put like another item like this, and you can adjust. And if you want to see you can see the full item or not, little bit higher or down. If you want it to in focus, you can touch on the screen and adjust it in the nice way so that you can see the whole item, and you can press S. And if you press on S, one good thing and one bad thing will happen. Good thing is that if you click on this guy, it will get the latest item. But the bad thing is that your previous scanned item would be gone, because this is currently replaced. So it's replacing, and it's the same name for every time you scan something. But we can easily fix this too with just maybe 2 lines of code. And to do so, all we need to do is to use a built-in package called time. So we will import, and that would be the time. And by using the time, we will create the current instance and current moment. So we will create here, say for example, time str, time string, and we'll call the time, and it will use the string time. And here you can pass any format string. So I will put like a %y. This will give you like a 4-digit year number, and then the m, small m, this will give you the month, and then you can do the %d, this is the date, and then dash will do like hour, this is the hour, and then capital M, which is the minute, and then capital S, which is second. You can actually see, like say for example, save, and maybe instead of this we will print out the time string. Let's see how does it goes. So if I click on this guy, now if I press S, you see this is a time stamp. This is the timestamp. If I press this again, this is like pretty much similar, but 4 seconds later. This is 3 seconds later. This is maybe another 2 seconds later. That means every time you press as, it creates a different name, and we can just convert this name as like an F string. It's not like the F you think. This is just a format string, and instead of this hard-coded name, you can make it dynamic. So inside this dynamic, we will put like a time str, and by using this, every time you press on S, it will create the pillow object of the image, get a new name, and then use that name to save the file. Currently, if you look at the folder, this is like my scan time. Once I will save any other scan, it will do a new one. So I'm trying to maybe scan this dude again, and I put here. And I put it here, I run this guy, and then you see this dude on the screen. I press S. Let's do 1 or 2 other more scans. So I put this guy, and then I press S. Maybe I do something else, right? And I press S. Maybe I have some other stuff, so many things to scan. Maybe I put like this guy. You might need to put little bit up and down, and since I don't have like whole things, but I can put like this whole thing right away. Maybe I will put in the right orientation like this, and pretty much you can press S. Maybe if I want to this text, there is so many things, and you can put it like up and down to get like a good clearance and resolutions. If you get the good clearance and resolutions in the good spot, and then you can just press S. So we have a kind of like open multiple items, but if you look into the folder, you'll see everyone has a different file. You see all this different file, and you can open one after another. So this is the first one, and this is the second one, and this is the third one, and this is the fourth one, and this is the last one that we scanned. So my dear friend, you were able to scan a lot of different things with different names, and that's the fun part of the scanner. Even if you want to like a full page, like if I have some kind of like a, let's say whether I have like a full page here, and I can easily scan that dude too. Say for example, I have a full page, I want to scan that full page. So here this is the full page, this is the full page that I want to scan. So I put it right here, and I put this camera. You might need to put it little bit up so that like you get the full picture of the image. So right now I have something like this, and if you get this full picture, if you don't get it, put it little bit up or down, and if you don't get it focused, just touch on the screen, and then once you think you are in a good shape, just or you're in a good position, press S. And if you have done this correctly, you come here and you want to see as an output, just open this, and then this should be the last one, and you get something here. But this is okay, we can stop here, and with just how many lines of code, with just maybe 15 or 16 or 17 lines of code, you got a good scanner, my dear friend. So if you watch this part, clap for us, put some lovely comment below for the grandma, like this video, and share this crazy project with your friend. But we'll do some little bit advanced part of it as well. If you noticed here, say for example, there are a lot of unnecessary things on the corner, and if you come here, there is a lot of unnecessary corner on the side. So to make it a smart scanner, so far we have dump scanner, which is dump. It doesn't know what is the object, how big of the object, but our goal is to make it as a smart scanner, and that we will do in our part number 3. To make your scanner smart scanner, you need another 8-9 lines of code, but that's super easy. We will do it step by step in a simple fashion. The first part, you need to do little bit image processing, and then you need to find what's inside in your image, and that's kind of like a smart image processing. And for doing this, you already have the frame. That means whatever you see on the screen, you got it, and this is what is showing in this output. So the first thing we will know that, okay, we already have the frame, and the frame by default is BZR. It has like a 3 layer of colors, and our goal is to convert it. So by default, if you run this guy, you will see something like this, right? This is me, very nice way. And if you convert the color, and you will get a different version of it. So it's very simple. You'd say like a frame, and then we say like a CVT, and you will call CV2, hey CV2, you need to convert the color, and you will have to tell what frame it would convert, and then second one, the color it would be converting. So CV2 will pass color, and then this would be BCR to RGB. So whatever the color order, this was previously was BZR, that means blue, green, red, and we are flipping it to RGB, red and then green and then blue, and it looks a little bit interesting. So if I run this guy, and you will see, okay, I'm not showing the frame, I need to show the frame and then CV2. So and if I show the converted frame, and this will make it a little bit fun, and I become genie. So now I am the Aladdin genie, and I have a lot of assets. If you have any wish, write in the comment below. Grandma will fulfill your wish. And once this is done, we need to little bit smoothen the image. Sometimes image is not a good quality, and that you can do another frame, and this is called like blur, and you can tell CB2, hey, you have some Gaussian blur. You can use the Gaussian blur, and you will pass the converted frame, and here you need to tell the kernel size, the size it will take to smoothen or take out the underdeveloped or some kind of stuffs, and you need to pass the sigma, the standard deviation, how it will do the smoothing or blurring part of it. And if you have a good quality image, you will not notice much about it, but if you have bad quality, you might see some changes, and you can play with these numbers. The last one you need to know is to detect the edges, because if I want to know the shape of it, I need to get the corner, right? Without getting the corner, you cannot detect the shape. Even if I want to use this guy, I need to get the corner to know the shape of it. So that's why you can have like, say for example, frame edge, something like this, and you will CV2, and Mr. Kenny uncle created a very fantastic algorithm to detect edges. And the first thing, we will definitely pass the previous frame that we have, and you need to pass the threshold, that how big or smaller corner it will detect. So I'm passing this to threshold 30 and 50, and this will create a kind of like a fun corners and edges. So if I run this guy, you will see these are the corners of me, right? You know, based on the light and the hands, you see those are here. Even if you take on the keyboard, this is my keyboard, right? You see all the characters are here, and you can take any object, say like you want to see. So I have some fancy object right here, and you see, so it detects the edges and corner, and it helps much easier for the image processing to detect object. And to do so, all we need to do is to like write 2 more lines of code, and this will give us the object that we want. So I'm coming back here, and we are done with the hard part. The next part is to detect some kind of objects, and that part is called contours. Contour is nothing but an object. You can think about the object. This is an object, this could be another object. If you want to get the shape or outer line of the contour, so we will get the contours, multiple contours. And if you want to get the hierarchy, you can declare a variable, the name age or hierarchy, but we are ignoring that, and we are telling CB2, all you need to is to find contours and give out all the contours you have. And here you will definitely need to pass the parameter that it will get, and the first one, you will need this frame edge, whatever the edge you gave, and then you need to tell how it will retrieve the contours. There are multiple different ways you can retrieve, but we are using, and this is RETR, retrieve, as a list, all uppercase. And the last one, as a parameter, you need to pass that how it will calculate or store the information. There are multiple different ways you can do it, and one option is to using a chain, and then it would be approximate simple, And be careful about the spelling here, and it's telling that you need to approximately know that how you will get the contour. For example, I'm giving a different example. If you know this is the line, you can store all the pixel points and you will get the line. Another option is say, okay, this is straight line, that means I'm starting this corner, this corner. If I know these two coordinate, I can easily draw the line. I don't need to remember every single pixel in between it. So that's how you're telling this opencv to be smarter to know it. But once you get the contours, the rest part is like easier, few more lines. If I can get some contours, then I want to get the biggest contour, because I don't care about the smaller, all these small edges and areas. I want to get the bigger one. I need the biggest thing, and for that purpose you can say like a max contour, and that you can use the default max function provided by Python, and you will pass all the contours you have, and you need to tell, hey, how you want to detect the biggest contour. And for this purpose you can pass the key, and this could be cv2, and that would be contour area. That means by using the contour area, you are telling Python, give me the biggest contour, the biggest area or biggest object you have. And once you have the max contour, and then you can find out different shapes. In our case, we are getting the rectangle shape of it. So you can tell, hey, I want to get maybe the height, width, and what is the coordinate system of it. That means x, which is the starting point and starting horizontal, y is the starting vertical, and then this is the total width and this is the height. That's what I want to get. X, y, the width and the height. And on the right side you will tell, hey, I want to get cv2, and then this is bounding rectangle. That means if it different shape, I want to get the boundary rectangle, something like this. And here you will pass nothing but your max contour. So if you pass the max contour, it will get all the coordinate system. And once you have the x and y axis, you can easily draw a boundary circle of the objects, and that's super easy. You say like, hey, cb2, you need to draw some rectangle. So it's a rectangle, and if you do rectangle, and you need to pass where it will be drawn. So this would be drawn on the frame, and then you need to tell this starting and end point. So starting point would be x and y, the end point. So if this starts right here, so for example, I will start with a bigger one. So this is the starting point, x and y. That means the ending would be x plus overall width. So that's how our second point would be x plus we will put the width, and the other one would be, this is vertical y, and the last end would be y plus height. So this would be y plus height. And once you have the coordinate system, next you need to define the color, what color it would be displayed. So I would put like a green and red, something like this, red and green, and then last one is like 2. So this is how you would be able to see the contour on the image. So let's give it a try. So I have this one, and then I will be putting on this. Let's see whether we'll get the contour. And this might give little bit hiccups up, but we'll fix it in a second. So if I have done so far correctly, right now what I am displaying is I need to change this here on this IM show. I'm doing frame edge. I want to show the frame. So I show this guy, I run this dude. You'll see if you take this correctly, you get some contour. But the problem is that sometimes you see the big contour, and sometimes it's kind of like the smaller ones, right? So if you want to ignore the smaller one, you can easily do that. So all I need to do is to tell, hey, if maybe you can play with this. So here, if you are drawing the rectangle, right, before drawing it, you can say like maybe here, okay, we can do it here. If you can say like a cv2, and you can do like a contour area of the max container is greater than some number. I'm putting say 5,000, something like this. Then you will draw it. So I put little bit indentation. That means you will only draw the max area if this area is greater than 5,000. So if I do this, let's see whether this works. Otherwise I will play with it. So I click on this guy, and then you see right now I don't see a lot of small stuff, but I see the big circle right around it. So this gives me little bit hope, and I can do some more cool stuff with it. So in that case, our objective is to save only the object, not the other part of it. So for example, if you look into the output that we have seen, in our case, all we need to do is to just get the item that we have. So here we want to get only this part of it, only this part of the item that we want to display. We don't care about like this area, and that's super easy. You can do it very easily. So here we have the frame. So right, for example, we are showing the frame, we can, and also we are saving it. We can put whole this block of code inside our if block. I just select all this line and press tab once and 2. Now it becomes inside this area. And here, other than getting the frame, what we can do here is to like say object only, something like this, and we can take a small portion of the frame. And the way it works is that first you provide the vertical one and the horizontal one. So you can say that here I will get from y to y plus h. Remember, here we did the vertical one, this was like y position and y plus h. So we get this slice, and then the next one we need the x and then x plus w. So we'll get like x, and from here we can do x plus w. That's pretty much we need to do to get the portion of the frame. We don't need the whole frame, we only need this area. And if it is this object, similarly we just need only this rectangle area. And after that, if you want to display, we can display, just copy here, this is the frame, and even we want to save it, we want to save with this area only. And if you have done this part, you would be easily save the item only that you want to scan. If you are scanning a driving license, your photo ID, or your maybe love card, or whatever you want to do, you can easily do that. So let's give it a shot. So I have this camera and this item put on the table. Let's do it like this way, and always you need to like put up and down to get a right focus. So let's run this guy. Maybe this one is this one could be like this. You see, you can all see the items, and if I press S, and this is already saved, and to see it as an output, this is the older one, like see it has all this other stuffs. And if I open this, say for example this same folder, right here I can open the folder. You see here I can open it in the Explorer, and here the last one should be the one. So if I open this, right, see this is the border. If you don't want to see the border, you can just cut the border, that I don't want the border. You can just comment out this line. This is the line which is adding a frame. So if you don't want this, you can easily press like, okay, I don't want this line, if you don't want this border, but I just keep it there, or maybe we can do just comment out this line anyway. So we have done scanning of like this item. Let's try something like this, little bit bigger one. Let's see how does it goes. So I'm putting it here. Maybe I am running this guy, and sometimes if you have like a larger items, you need to play with little bit, like, you know, to have the whole things. Maybe align it little bit, and once you are in a good shape and you feel like a little bit comfortable, you press S, and you say this is saved. So now I am going to this dude and then open this guy, and I see I got the item. And similarly you can play with other stuffs. Say for example I have this one, maybe try with the text. So another text, this tiny text I have here. Again you need to go to here, and based on your phone camera lightings, sometimes make sure the resolution is good, and then press S. If you have pressed S, you will see definitely a signal that this is saved, and you can go to the folder. You see like another file added, and you see like this guy. If you want to like if I have anything else, maybe this is the Jeff Bezos uncle's phone that I got for this video. Let's play with like Jeff Bezos little bit. And then the Google Pixel phone, you see already Google Pixel phone right here, right? And then this is the back of this one, and then if I save it, this should be saved if it is saved, and then another file would be there. And like this. Sometimes this could mess you a little bit. Say for example, if it is a really large space, something like this, it might not be coming on the screen, or maybe sometimes it would be detecting only portion of the area. If you have like this problem, you just get rid of the object only. So instead of the object only, you can just say like, okay, I want to see the frame, the full frame, whatever the camera is seeing, and I want to save the full frame. So sometimes say like you have like so many objects, right? And if you don't get the whole thing on the screen nicely, in that case you can go back to the basic format. Say like I want to get the full items, because it has so many small areas, and sometimes you are not detecting the whole thing. So you can go back to the frame and you run this guy. Now you'll get the whole things and you can save it, because this is a large piece of paper anyway, and you can do all this stuff. But if you want like a tiny things like a driving license or anything smaller, you can come back to these options where you are getting the object only and you are showing the object only and saving it. So that's pretty much the way you would be able to actually create your smart scanner that can scan a small part of a document, and only the small piece would be scanned, or the full document could be scanned as well. So, and all you have to do is to write how many lines? 27. Maybe if we take out this line, it will become a 25 lines of code. And if you have watched until this point, you have to share this video with your friends and write some romantic, lovely comment about grandma. And if you have some fancy idea, and that could be our next cool, exciting project, please comment in the below. And if you get any error while trying out this project, please join the Discord channel, share your screen and take a screenshot of the error, share with us, and our team will help you with every single problem you are facing with this project. And if you watched until this point, you have to use a fancy app called Programming Hero. So you just need to go to the Programming Hero and you can go to the website and get the app. It could be the Android or iOS app, whatever you want, and then learn Python in a fun and fancy way. And also you can add some lovely romantic review. This is by far the best review of the learning app. So with your love, grandma will keep adding more fancy projects. So that's all from this video. Your grandma, and I will see you in the next video.